Hello, this is Tony. I am a math and science tutor here at OpenWisdom Education. Today we're going through the 2020 HSC Physics paper, specifically targeting Module 5, Advanced Mechanics. Feel free to pause the video right now and have a go at the question yourself. Otherwise, I'll be going straight into the solution. So as you see here, I have highlighted any key components of the question. With any long response question like this, you want to understand what kind of topics there are and what kind of equations will be needed to answer the question. And you see that I have also highlighted the marks. It's because in an exam situation, time is very important. For a 6-marker like this, I recommend 6 to 8 minutes to complete the answer. And how you structure answers is also very important, with what relevant content that can save you a lot of time. So before we go into the question, let's go through a quick overview of the background knowledge. So we see from the diagram here that it looks like anything to do with orbital velocity. And the most important part regarding that section, we have looked at Kepler's law of planetary motion. The first one, which states that the orbit of the planets about the sun is elliptical in shape, with the center of the sun being located at one focus, which is the law of ellipse. And the second one is the law of equal areas, an imaginary line drawn from the center of the sun to the center of the planet will sweep out equal areas in equal intervals of time. And a third one, which is just the formula itself, the ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distance from the sun. This formula can be found on your formula sheet. And since we're accounting for changes in velocity, we also have to take into account the relationship between gravitational potential energy as well as the kinetic energy. I have included the relevant syllabus dot point here in case you want to do any additional research or revision into the specific part. Now let's go on with answering the question for a 3-marker like this. Account for the changes in velocity of the comet as it completes one orbit from position P. So we recognize that this is asking us about one of the specific laws, Kepler's second law, which that planet moves distance x and distance y in the same amount of time. Area x equals to area y. So we know that it's the second law, and the important part is that we have to mention equal area covered in equal time. Now combine that, we can say the comet must travel at a high speed when it's closer to the sun in order to cover the equal area. And the gravitational potential energy is turned into the kinetic energy as the comet travels towards the sun, which here you can also mention law of conservation of energy, including a quick definition, and concluded with that increase in kinetic energy also is the same as increase in velocity in this situation. So covering all the key components, that's how you answer a 3-marker like this. Now let's move on with question B. 2 stars A and B of equal mass m, separated by a distance x, interact gravitationally such that the speed of A is constant. Derive an expression for the speed of B. So just because it says it's a derivation question doesn't mean that it's specifically just calculation. We want to go through some of the background knowledge required to actually derive the correct expression. So we know that constant speed means that the motion should be circular. And in that case, the gravitational force will also be equal, such that A and B, if they must orbit a common mass, such that the center of the orbit will be half of the distance between the 2 stars. Knowing that, we can apply that into the formula we already know, that the gravitational force would be equal to the centripetal force. Both formulas could be found on your formula sheet. In this case, GMM over x squared, with x being the distance, is equal to mv squared over x on 2. So remember that the distance will be halved. And after the conversion for v to be the subject, we found that v is equal to root of gm over 2x. Now, I have also included here any sample answers from NASA. It's also very important for you to go through any answers the NASA website provides, as they usually give a good indicator of what markers are looking for when they read your long response question. And the criteria can also be used for you when you do your own response and you want to check yourself to see if you marked exactly what they want.